Alright, section 2.2, we're going to be moving up and solving two-step equations. When we're solving two-step equations, we're going to continue to use inverse operations. That'll never change as we're solving any length of equations. However, our steps, we do have a couple steps that we need to keep in mind. We always want to do addition or subtraction first, depending on the problem, and then followed by multiplication and division. So it's almost like order of operations in reverse. There is one exception, and if we have one side written as a fraction with more than one term in the numerator, we want to multiply first. That'll just eliminate that fraction. Okay, and we'll have an example of that so that makes a little bit more sense. So right there, x minus 7 over 3 equals negative 12. The one side is a fraction. Alright, so let's look at our first example of two-step equations. 2x plus 11 equals 1. Okay. For solving this, we want to do addition or subtraction first. So in our problem, it says plus 11. The opposite of adding 11 is then subtracting 11. So we're going to subtract 11 from both sides. When we do so, the 11's cancel, and we have 2x equals negative 10. Keep those integer rules in your mind because we're going to be using those a lot when solving equations. And now we're down to multiplication division. It says 2 times x, so we're going to do the opposite of multiplication and do division. So we're going to divide both sides by 2. That leaves us with an answer of x equals negative 5. Checking our work, start by rewriting the original equation. Next, plugging in negative 5 for x. We have 2 times negative 5 plus 11 equals 1. So we have negative 10 plus 11 equals 1, and now 1 equals 1. Great. We did that correctly. Alright, next example. X over 2 minus 4 equals 8. Apparently I got ahead of myself. So addition, subtraction first. It says minus 4. So what we need to do is then add 4 to both sides. So when we do that, we are minus 4 plus 4 cancel. We're left with x over 2 equals 12. Multiplication division. X over 2 is division, so we need to do the opposite and multiply by 2 on each side. So when we multiply by 2 on each side, the 2's cancel, we'll get x equals 24. And then here's our fraction example that I have. X plus 5 over 6 equals 15. So we're going to go out of order. We're going to eliminate that fraction first, and we can do that by multiplying both sides by that denominator, which is 6. So when I multiply both sides by 6, on the left-hand side my 6's cancel, and then I'm just left with that numerator, x plus 5 equals, and then 15 times 6 is 90. And now notice it's a one-step equation. I've already done my multiplication slash division, so I have my addition subtraction left. So since it says plus 5, I need to subtract 5 from both sides. X equals 85. Alright, and I have a word problem in here for us. Just it's nice to work through one of those together instead of always working through those by yourself. So you go ahead and make sure you pause the video so you can get this word problem into your notes. A train is 100 miles away from a station. It is approaching the station at 40 miles per hour. How long will it take for the train to arrive? Okay. Well, first let's define some variables. Let's use the variable h to represent hours because we want to know how long will it take to arrive. Okay. We know that the train is traveling 40 miles per hour. So anytime you're approaching a word problem, write down what do we know. Okay. So just kind of walking through this 2 hours, we would take 2 times 40 because if we're doing 40 miles per hour, taking it times 2, we're going to travel 80 miles. So using that just kind of helped me. What math operation are we doing here? Since we took 40 times 2, 2 is just the number of hours we were using as a test, we're going to write 40 times h. Because right now we don't know how long it's going to take the train to arrive, but we do know the train is going to travel 100 miles. So we have it equals 100 miles. Now that we've set it up, it's a one-step equation. We can solve by dividing both sides by 40. By doing so, we get that the train it'll take 2.5 hours to arrive.